This is video tutorial number 9 of the Europe-LAND Toolbox video tutorial series. In example 2, we explore how wildfire events reshape land uses and land cover, and how these changes relate to flood risk. Example 2 focuses on wildfires reshaping land uses and land cover versus flood risk. The study area covers the regions of Leiria and Coimbra in Portugal, which have experienced major wildfire events during the study period. The analysis uses multiple data layers and tools: NUTS, administrative boundaries, elevation, CORINE land cover from 2000 and 2018, imperviousness density, tree cover density, flood-prone potential areas from the European Environment Agency, and the compare tools, in particular the slider tool. The purpose of this example is to evaluate how major wildfire events reshaped land uses and land cover between 2000 and 2018, and to analyze how the expansion of burnt and deforested areas intersects with flood-prone zones. The example supports evidence-based planning by helping to identify increased flood, erosion, and debris flow risks, prioritize flood protection measures, guide infrastructure reinforcement, inform post-fire reconstruction, and enable safer land use planning and future development. This example is relevant to a wide range of stakeholders, including regional and national civil protection authorities, disaster first responder agencies, forest management and reforestation authorities, municipal spatial and urban planning departments, water infrastructure agencies, landowners and rural communities, infrastructure operators, and insurance companies and risk assessment consultants. The innovation of the Europe-LAND Toolbox lies in its ability to enable rapid post-disaster landscape assessment by combining wildfire-affected land cover changes with flood and erosion hazard datasets in a single interactive environment. Through instant layer comparison, using tools such as the slider and integrated open data sources, the platform supports cross-hazard analysis, from fire to erosion to flood, which is typically difficult without specialized GIS tools. This provides authorities and planners with a fast and intuitive decision support workflow for prioritizing interventions in highly dynamic, climate-impacted landscapes. This slide presents the so-to-speak cheat sheet of Example 2. If you have already watched this video and you want to replicate Example 2 on your own, we suggest you pause the video here and use the cheat sheet for assistance. If you need more help, or if this is the first time you watch this video, we suggest you continue to watch and perhaps try to replicate what you see, pausing the video if necessary whenever you need to. This slide actually briefly presents all the steps you should take in order to recreate Example 2 as shown in this video tutorial number 9. On the left, you can see the exact buttons/layers/tools you must click and use. For example, step 1 includes the following. You start by clicking the Data button in the Data panel, then you must click the Layers button, then you must click the NUTS Regions button, and then you must click Level 0 button. This was step 1 of the 8 steps of the main part of Example 2. Then you just follow the next steps, while on the right of this slide, you can see the respective steps of some additional features we will check. Let's now test Example 2 together, using the relevant layers, features, and tools of the Europe-LAND Toolbox. This hands-on walkthrough will help deepen your understanding of how wildfire-driven land cover changes can be explored and linked to flood risk. So, in the toolbox, the pop-up welcome screen must be closed first. Let's now test Example 2. We start by navigating to the study area, between the regions of Leiria and Coimbra in Portugal. Click Layers, then go to NUTS Regions, and select Level 0. It automatically zooms out to the full extent of Europe. Click inside Portugal and see the overall distribution percentages of latest land uses. You can also click Export PDF to download these statistics in PDF format. Now add NUTS Regions, Level 3. Again, the map zooms out automatically. Let's zoom back into the study area and focus on the regional units of Leiria and Coimbra. Notice that the Layer Manager lists the layers in the exact order we clicked them. Next, go to the European Environment Agency, EEA, and load the elevation layer. It may take a few seconds to load. Now we can see the topography and infer slopes, which are important for understanding how landscape conditions can influence flood processes. Next, go to Copernicus and load CORINE Land Cover 2000. We can also see the legend. In CORINE 2000, we observe that the mapped burnt areas are relatively limited in extent. Now load CORINE Land Cover 2018. It below CORINE 2000 in the layer manager, meaning it was added later and is actually one level in front of it. By comparing CORINE 2000 and CORINE 2018, we can clearly observe that burnt areas expanded significantly between 2000 and 2018 in parts of the study region, reflecting the impact of major wildfire events on land use and land cover patterns. Let's now load the imperviousness density layer for 2018. Because this layer is transparent, we can toggle other layers on and off and overlay it to inspect sealed surfaces and urbanized patterns in relation to the land cover changes. Next, load the tree cover density 2018 layer as an additional indicator of vegetation conditions and post-fire recovery, allowing us to relate changes in tree cover to the previously identified burnt areas. Finally, load the flood-prone potential areas layer from the EEA. It may take a few seconds to load. Flood-prone potential areas overlap on top of CORINE 2018. Toggle CORINE 2018 on and off. At this stage, users can directly and visually inspect where burnt or deforested land cover patterns intersect with flood-prone zones, using a single interactive environment without the need for external GIS processing. These intersections help highlight priority areas for attention by decision makers and stakeholders, especially in upstream catchments, where post-fire conditions can lead to increased runoff, erosion, and debris transport, ultimately increasing downstream flood risk. Let's now check how the compare tools can help us visually inspect relationships between layers and draw spatial and temporal conclusions. The respective cheat sheet is also shown here. In the Compare panel, click Compare button and then the slider tool. This corresponds to Example 2, Additional Features A in the cheat sheet. Let's select as a left layer CORINE 2000 and as a right layer CORINE 2018. Let's zoom into the study area of Example 2, covering the regions of Leiria and Coimbra, Portugal. Using the slider, we can directly compare pre- and post-wildfire land cover conditions, clearly visualizing how burnt areas expanded between 2000 and 2018. This comparison also reveals that areas that were previously burnt did not recover to coniferous forests again, but transitioned to other broad-leaved forests or low vegetation, indicating long-term landscape change. Next, let's compare CORINE Land Cover 2018 with flood-prone potential areas. This corresponds to Example 2, Additional Features B in the cheat sheet. After the right layer loads, we can inspect how burnt and deforested areas overlap with flood-prone zones, particularly along the hydrographic network and valley bottoms, where the rivers and streams flood their banks and riparian areas. Finally, we compare imperviousness density 2018 on the left with flood-prone potential areas on the right. This corresponds to Example 2, Additional Features C. This concludes Example 2, Wildfires Reshaping Land Uses and Land Cover versus Flood Risk. Through this example, we examined how major wildfire events reshaped land cover patterns between 2000 and 2018, and how these changes intersect with flood-prone areas, particularly along river networks and upstream catchments. The analysis highlights how post-fire landscape transformations can increase flood, erosion, and debris flow risks, underlining the importance of integrated cross-hazard assessment. Using the Europe-LAND Toolbox, these relationships can be explored quickly and intuitively by combining multi-source open datasets and interactive comparison tools, without the need for advanced GIS expertise. This demonstrates the Toolbox's value as a decision support platform, enabling authorities, planners, and stakeholders to identify priority risk areas, support evidence-based planning, and enhance climate-resilient land and water management in fire-affected regions.